Hey guys, it's Tiffany from supereasymath.com. Today we're going to do a worksheet fill-in over multiplying and dividing equations. Don't forget to head over to my website and click on printables to get your copy of this worksheet. Multiplying and dividing equations. Worksheet fill-in. Let's take a look at our worksheet. It says solve for the variable. What that means is get the variable or the letter on one side of the equal sign by itself. So for example, number 1, I have 4p equals 32. So right now, on the left side of the equal sign along with the p, I have a 4. The relationship between the 4 and the p is multiplication. The way I know that is because they're touching. The opposite of multiplication is division. We have to use the opposite of whatever is there to move the numbers around. So I need to use the inverse operation, which is division, to get the 4 to the other side of the equal sign. So what that looks like is I'm going to divide the left side by 4 and the right side by 4. Whenever you're undoing something, you basically cancel that out. So I don't really have to work out 4p over 4. I just know that the 4's cancel out and I'm left with just the p. So on the left, I just have p. And then on the right, I'm going to divide 32 by 4. And when I do that, I get 8. So my answer to number 1 is p equals 8. Now, if you wanted to check your answer to make sure you got it correct, all you need to do is plug in the answer you got for that variable back into the original problem and make sure what you get on the left side equals what you have on the right side. So that means for this particular example, I would rewrite this as 4. And instead of writing a p, I'm going to write 8. But I need to make sure it's clear that I'm multiplying the 4 times the 8. If I were to just write the 8 down, it could look like 48 to me, and I might be confused when I come to look at that later. So I want to make sure I understand that I'm multiplying by 8. So I could draw like a dot and then 8, and it would look like this. Or I could draw 4 and then put 8 in parentheses. Or I could put a 4 and then an X, like for a multiplication symbol, and then 8. All of these right here, all of them mean 4 times 8. So it doesn't matter which way you write it, but you do want to put it in some kind of way to clarify that you need to multiply those two things. If you were to just list the 8, you might mistake it as 48, like I said. So anyway, let's say we go with the dot. Let's say we go with the 4 dot 8 to represent multiplication. I want to make sure that equals 32 because that's what I had on the right side of my equal sign in the beginning. And if you know your multiplication facts, or if you can at least calculate it, you would know that 4 times 8 does in fact equal 32. So this is like saying 32 equals 32. So that is correct. Now let's take a look at example number 2. For example number 2, I have the problem 5b equals 90. This is saying 5 times some number that I don't know what that number is yet equals 90. So if you remember, I said we have to use the inverse operation to move things around so that we can isolate our variable. So right now on the left side of the equal sign with our variable b is the number 5. So the relationship the 5 and the b have with each other is multiplication right now. Like if you were to try to work out this problem the way it is, it's telling you to multiply 5 times the b. So to undo that would be the same thing we did on the left in example number 1 is divide both sides by the 5 because that's going to move the 5 away from the b. So I'll divide by 5 over here and divide by 5 over here. The 5's cancel out and I'm left with just b on the left side. And then that equals whatever the answer to 90 divided by 5 is. I want to make sure you remember that whenever you see something like this, a fraction, and there's a number in the top and a number in the bottom, really that means division. Okay, all fractions mean division, but you may not be dividing when you look at one right away. But in this type of scenario, in this type of situation, you would divide. So this is like saying, put 5 on the outside and put 90 underneath. Now you're going to divide 5 into 90, and you would get 5 goes into 9 one time. You subtract, you get your 4, bring down 0. And then 5 goes into 40 8 times. So you get 18. So b equals 18. Now, just like I did for the past example, I'm going to show you how when you plug in the value for 18 into your original equation, you're going to get a statement that's true, and that's going to be your confirmation to know that what you did is correct. So I'm going to start by rewriting the original problem, which was the 5b equals 90. So I have 5, and instead of writing b, I'm going to write 18, and I need to write it in some kind of way to let me know that I'm doing multiplication, not just write 18, because then I'll think I have 518. Okay, that's going to confuse me. So I can put it in parentheses, and then that should equal 90. Well, to check it, you're going to multiply these two numbers. You're going to say, okay, well, what's 18 times 5? And so you can set that up. You can say 18 times 5. Well, 8 times 5 is 40. And then 5 times 1 is 5. And then add my 4, and I get 90. So yes, 90 would end up being on my left when I multiply these two together, and that equals 90. So because they equal each other, that means I answered it correctly. Now let me show you, let's see what would happen if you got the wrong answer, how you would know that you were not on the right track. So let's say you did all of this work that I did here in red, and somehow when you finished, you got b equals 4. This basically means you did your work wrong somewhere, but you don't know that in the moment, right? You're like, okay, yeah, I got my answer. I'm all happy. B equals 4, yay. Well, you're gonna know that your answer is wrong when you go plug it back into your original equation. Let me show you what that looks like. It's 5, and instead of b, I'm gonna write the 4, and then I'm gonna write equals 90. See, this is the exact same as my original equation, but what I did was I plugged the value that I got for b into it. So now I have 5 times 4, and that gives me 20. And then I would still just need to rewrite my equals 90. Well, now I'm asking myself, is this a true statement? Does 20 equal 90? No. So that means I did something wrong. And I do want to point out that you could have done something wrong in your original work, or you could have actually done something wrong when you went to check it. Like when you went to plug in your b equals 4, you could have done something wrong right there and messed up, okay? So keep that in mind. If you don't get something that equals something else in your equation when you're checking, that means your answer is wrong. Something is wrong somewhere, okay? You messed up somewhere. You're always looking for something to equal itself, okay? Now let's take a look at problem number 3. Number 3, we have x times 3 equals 96. Well, right now, we want to get that variable by itself on the one side of the equal sign, so that x needs to be on the left side of the equal sign. Right now, I have a times 3 over there with it, so I want to undo that. Instead of times 3, I need to divide by 3. Remember, division is the opposite of multiplication. This time, we are going to write our division in a way that looks a little different on the left, okay, than what we did for examples 1 and 2. In examples 1 and 2, we made our division into what looked like a fraction. This time I'm going to use like that old school division symbol, the line with the 2 dots, okay? So I'm going to divide both sides by 3. And then actually you can write it however it fits. So on this right side, I'm actually going to continue with the little fraction look. This means both sides are being divided by 3. It doesn't really matter how you write it. It just matters whether you understand it or not, okay? So if I have a times 3 and a dividing by 3, that cancels itself out, okay? That's like nothing now. So on my left side, I'm just left with the x. Now that's going to equal whatever 96 divided by 3 is. And when you divide that, let's see, 96, put a 3 out here. 3 goes into 9 3 times, that's 9. Subtract with a 0, got 6 to bring down, goes in here 2 times. That's 6, you get 0. So you get a nice 32 with nothing left over, okay? When I get a 0 down here at the bottom, I know it's time to stop. It means I'm done with my division. So anyway, I get 32 when I divide 3 into 96, so x equals 32. Now, if I want to check to see if my answer is correct, I'm going to plug that 32 back into my original problem. So remember, my original problem was x times 3 equals 96. So what that's going to look like plugged in is 32 times 3 equals 96. Well, I need to calculate 32 times 3 and see if I get 96. Let's do it. 32 times 3. 3 times 2 is 6. 3 times 3 is 9. How about that? 96 equals 96. That means my answer is correct. That means I'm on the right track. I'm doing it. Okay, I'm doing a great job. Example number 4. This problem is 42 equals 6 times k. I want to get that k by itself, and it's okay if I get it by itself on the right side. I can do that. Now, typically, I prefer to write my answers with the variable equals something else, meaning your variable on the left, and that equals some mystery number, okay? Whatever number you're going to calculate for your answer. But if you end up with your answer in reverse, where you have your mystery number, and then that equals your variable, that's perfectly fine too. You can just switch it if you want, and that's equivalent. And this is like saying $1 is equal to 4 quarters, right? So wouldn't it be true to say 4 quarters equals $1? It's kind of like, what difference does it make which side each thing is on, okay? So I just want to point that out. So what I'm going to do is I'm going to get that k by itself. And right now I can see that the 6 and the k are being multiplied together. So to undo that, I'm going to do division. So I'm going to divide by 6 on both sides. The 6's cancel out, and I'm left with a k on the right. And 42 divided by 6 is 7. So 7 equals k. Or if you want to reverse it like I explained, because I do prefer to have my variable listed first, you would write k equals 7. Okay, same thing. It's just like $1 equals 4 quarters. 4 quarters equals $1. Does it really matter the order you write in? It really doesn't. Okay, so you just switch it and make it look better. Now I'm going to plug the value of 7 back into my original equation to see if my answer is correct. So I have 42, and that equals 6. And I'm going to put my 7 in parentheses to clarify that I am multiplying right there. Now this is a multiplication fact that you at least probably have seen. If you don't have it memorized or you've forgotten it, it's okay. But 6 times 7, which happens to be my favorite multiplication fact, does equal 42. So 42 equals 42. So what does that mean? It means we're doing it right. Our answer is correct. Now let's take a look at example number 5. Example number 5 says f times 17 equals 136. So I'm going to divide by 17 on both sides because that's the opposite of multiplication. This time I chose to use the division symbol. Doesn't really matter as long as you know what you're doing. This says f equals whatever 136 divided by 17 is. So I can see that because of the nature of my two numbers that I have, I'm basically just going to have to guess a whole bunch of numbers to multiply 17 by to figure out what goes in 136, because 17 can't go into 1 and it can't go into 13. So I'm just going to have to figure out how many times 17 goes into 136 in the first place. So it's kind of like I'm just going to have to guess numbers that I can multiply 17 by. So let's just start with like 5 and see what that gets us. I'm totally guessing. I'm just like 5. Let's try it. 5 times 7 is 35. 5 times 1 is 5, and then plus the 3 is 8. Okay, 17 times 5 is 85. That's too low. So I need to go up, right? Because 17 times 5 doesn't give us what we need. So now I'm going to say 17, and then how about I say, well, let's see. In my head, I'm going to think, well, if I doubled this, which would be 17 times 10, that would be 170, right? Because any number times 10 is just add a 0 to it. So that would be too high because I'm only looking for 136. So let's go kind of like middle of the road. What if we try like times 8? 17 times 8, let's try that. Okay. 7 times 8 is 56. 8 times 1 is 8. Plus the extra 5 is 13. Oh, how about that? It's exactly 136. So the answer is 8. And so that means I'm going to subtract 136. I get a 0. And that tells me it's time to stop dividing because I got a nice 0 and there's nothing left to break down. So what this means is 136 divided by 17 is 8. So The only thing left to do, like I've shown you in the rest of this video, is plug in the value that we got for the variable into our original equation to see if we get something equals something. Okay, so I have 8 times 17 equals 136. Well, this one's kind of easy for us to get through the checking process because we just did 17 times 8 over here and we got 136. So we know it's 136 unless you did your multiplication wrong right here. If you messed up right here, then maybe it could be wrong. But, it doesn't hurt to go ahead and do it again. You can say, okay, I'm going to try one more time to make sure what I got was right. And guess what? You get the same old thing. What does that mean? You're on the right track. Now let's go to the next page. Example number 6. Example number 6. Well, the first thing I noticed about example number 6 is this is our first division problem, meaning this is the first problem where they're giving us the equation that has division already in it. The first 5 problems that we just had gave us an equation that had multiplication already in it, and to undo the multiplication, we had to do division. Now, this side is going to be reversed. 6 through 10, we're going to do the opposite. We're given division, and we need to undo it with multiplication. So that's the first thing I'm noticing. The second thing I notice is this problem looks like it should be on the easier side because we got an awesome number, which is 10. I love working with 10s. 10s mean, hey, you can just add a 0 to the end of something if you're multiplying by it, or if you're dividing, you just change the place value a little bit. It makes your math easier, okay? So I know that if I were to multiply something by 10, I'm going to give it a 0. So the opposite is going to be the case when I'm dividing. In this case, I'm dividing. So I can look at this already and already tell that the value for A is going to be 630. But if you're not there yet, if you can't see that, let me show you how to get there, okay? So because A divided by 10 equals 63, I know the inverse operation would be multiplying it by 10 because that's undoing that. So I'm going to multiply by 10 also on the right. Remember, when we're dealing with equations, we have to keep the equation balanced. So that means anything you do on the left side, you have to do to the right side. If not, it's not an equation anymore, meaning it's not equal anymore. In fact, before I continue this, let me take a little tangent and show you what I mean, because sometimes I don't think students get that. And when you get that, it's going to help you calculate your answer easier. If I have the problem, like an easy problem, like 4 plus 3 equals 7. That's a pretty easy problem, right? If I have 4 apples and I add 3 apples, I know I'm going to have 7 apples, right? Well, let's say I want to do something on one side of this equation. So on the left side, where I have the 4 plus the 3, let's say I want to multiply that by 10. I'm choosing to multiply by 10 just because it's like the same thing that we have over here. Let's say I say, okay, well, the 4 plus the 3, that's 7. And then I'm going to multiply all that by 10. And let's say order of operations tells us to do the top first. So I'm going to multiply all that by 10. And then you're going to end up with 70. So 70 equals 7. That's not true. However, watch this. Here it is. If you were to multiply the right side by 10, then your 7 times your 10 would also equal 70. Oh, and they'd be balanced, okay? You can't do something to just one side because it's going to make your equation not balanced. You have to do it to the other side also, okay? So let's change it. Let's say you had 4 plus 3 and that equaled 7. Let's say you weren't multiplying by 10, you were doing something even easier. Let's say you were just adding 1. So let's just squeeze it in real quick. Let's say I had plus 1 with it. So it'd be 4 plus 3 is 7, plus the 1 is 8. Well, 8 does not equal 7. But what could I do to make sure it remains the same? It remains the same number on both sides. I would have to add 1 over here, okay? So I would end up with 8 equals 8 when I do that. So now I'm going to cross this one out because it's no longer relevant because we added the 1. So it ends up being 8 equals 8 now. So this is the reason we have to do the same thing on both sides. If we don't do the same thing on both sides, we're not going to end up with an equation that is equal, okay? That's the whole point. The equal sign is telling you everything that's on the left is equal to everything that's on the right. They're just in a different form, okay? Just like money. Let's say, I'm gonna do that money example again because I think it's the best example I've ever thought of that makes the most sense of what's happening with the math, right? So if I have a $1 bill, right? My $1 bill, yay. And this looks nice and fine. This is like my 63, let's say. Now on my left, it's like saying, okay, well, you got 2 quarters. Well, that's 50 cents. And then you have 5 dimes. So 2 quarters plus 1, 2, 3, 4, 5 dimes. Okay. And that equals $1 too. Yeah, that's perfectly true. But what if you said something like, hey, let me add a nickel over here. Would these be equal now? Would this side be equal to what's on this side? No, it wouldn't. So in order to make your right the same value as what your left is, you would also have to add a nickel over here. That you have to do the same thing on the left side that you do on the right side. It has to be balanced in that way. If you don't do it on both sides, then you're gonna have a problem because your equation is no longer balanced. Okay, so back to number 6. I went off a little bit because I wanted to make sure that was understood. It's like, sometimes I think students are like, oh, just memorize all this stuff to do. It's like, no, don't memorize a whole bunch of stuff. If you understand what's going on, then it'll make sense to you what to do. So to me, it's very sensible to do these steps because I get what needs to happen. So just like with the money, if you understand like, hey, one side has to be the same as the other side, then it's going to make sense to you that you have to do the same operation on both sides. It's not going to be like something you have to think about so much. It's like, oh yeah, I have this is the only way. It's the only way this is going to like be workable, right? So now, if I did multiply both sides by 10, like that was my first step, and then I'm going to cross off that and I'm left with just my A on my left. Well, then that's going to equal whatever 63 times 10 is, and that would just be 630, okay? Remember, whenever you're multiplying by 10, you just add a 0 to the other number. So it's A equals 630. Now, if I wanted to check, I'm going to plug in 630 into my original equation. So I have 630, and that is divided by 10, and that should be 63. And it is, because 630, if I needed to set it up, divided by 10 does give you 63, because 60 doesn't go into 6, but it goes into 63 6 times, and that would be 60, and you subtract and you get 3, and you bring down 0, and then 10 goes into 33 times, right? So you get 63 equals 63. Yay. Now let's take a look at example number 7. I have J divided by 7 equals 19. Again, we've been given division. So to undo that, we need to do multiplication. So we need to multiply both sides by 7 because I got to get whatever's over there with that J away. So the way to move that divided by 7 is to multiply by it. But on both sides, remember, get rid of this. J is left, and then that equals whatever 19 times 7 is. And I'm like, I don't know what that is, because most people don't learn their 19 times table. So sometimes you gotta work it out. Calculator, do it by hand, whatever you need to. 63 is 9 times 7, and then 7 times 1 is 7, and then plus the 6 is 13. So I'm left with 133. Now I want to check my answer, so I plug everything in. I put 133 divided by 7, and I want to make sure that gets a total of 19. So now I'm going to divide this, so that means, long division, 7 into 1, 3, 3. And when I do that, 7 goes into 13 one time, and that's 7 subtract, I get 6, bring down the 3, and 7 goes into 63 9 times. So 133 divided by 7 does give me 19, and so 19 does in fact equal 19. Now let's take a look at example number 8. Example number 8, I have R over 22 equals 27. Well, I'm going to multiply both sides by 22. My 22 times 22 over here just cancels out. And I wrote right over that 8. I hope that didn't bother you too much. I'm just like pretending like it's not even there. And I'm left on the left side of my equal sign with just the R. And that equals whatever 27 times 22 is. If you don't know what it is, you come over to the side of your paper, you work it out. And in this case, that would look like this. 2 times 7 is 14. 2 times 2 is 4. Plus the 1 is 5. Add a 0 for my next row. Then it's going to be the same because it's another 2. So sometimes when I see little shortcuts like that, I'm like, ooh, a shortcut. So anyway, I'm like 54. Then I add this, and I have 4, 9, 5. So R equals 594. Now I want to check my answer. So instead of R over 22, I'm going to write 594 over 22, and hopefully that equals 27. Well, this part needs to be divided. So I'm going to put the 594 underneath and 22 on the outside. If you get mixed up with this, because I've had that happen a lot, students will think. And I believe that is my equivalent fractions and decimals video. Anyway, now let's take a look at this. I got 22 and I need to divide it into 5. Can't do it, so I'm going to go to the next place. 22 goes into 59 2 times, and that is 44. And then I'm going to subtract, and I get 15. Then I bring down my 4, so I have 154. And 22 goes into 154 exactly 7 times. That's 154. When I subtract, I get 0. Ended with a 0, so I'm done. So that means this right here, this stuff right here, just turned into 27, okay? So that's 27 equals 27, and that's correct. Example number 9. I got a T in my numerator and a 9 in my denominator. Well, I'm going to multiply both sides by 9 because I want to get that 9 away. And right now, this is saying T divided by 9. So now I'm going to do T multiplied by 9. So 9's gone, left with T. And now I have 73 times 9 is 657. And the way you get that is just by multiplying. You take your 73 times your 9, and you say, well, 9 times 3 is 27. 9 times 7 is 63, plus the 2 is 65. So you see, same thing. That's where that came from. Okay, now I'm going to check my answer. So I'm going to plug in the 657 into my original equation. And so that means I have 657 over 9, and hopefully that equals 73. It does. I'm just showing you what to do. But 657 divided by 9. Well, you say, how many times is 9 going to 6? I don't know. You can't do it. Well, no. So you ask yourself, how many times is 9 going to 6? Can't do it. So you take one more space. How many times is 9 going to 65? It goes in there 7 times, which is 63. You subtract, you get 2. Bring down 7. How many times is 9 going to 27? 3 times. It's 27. So you subtract, you get 0. This 0 tells me it's time to stop. This part of the problem just turned into the answer, 73. So that's 73 equals 73. So that means I got it correct. Now it's time for our final example. I have 583, and that equals Z divided by 11. Well, Z is what we want to get by itself. And right now we got this division of 11 over here with it. So I'm just going to undo that by multiplying by 11. This is gone. I'm left with Z over here. And then I have 583 times 11. And, you know, most people are not going to know that. So you just work it out. Thankfully, we have 1, so it's going to make our multiplication way easy. It's just going to be the exact same number on this top row, and then you add a 0, and the exact same number on the bottom, but just a 0 added at the end. Then you add. So you have 3, 8 plus 3 is 11, 8 plus 5 is 13, plus 1 is 14, and then 5 plus 1 is 6. So 6,000, and you can, or you don't have to write a comma, but I will this time. 6,413 equals Z. Or, like I showed you in a previous problem, you can switch it and say Z equals 6,413. And now I want to check my answer. So I'm going to plug in the Z value into my original equation. So I have 583, and that equals, what is Z? Z is 6,413 divided by 11. Well, 6,413 divided by 11, what does that equal? You have to calculate it. So I'm going to say 6,413 divided by 11. And you say 11 can't go into 6, so I'll go to the next number. 11 can go into 64. That would be 5 times. And it's 55. And then when you subtract, you get 9. And you bring down your 1. 11 goes into 91. 8 times, and that's 88. You subtract, and you get 3. And you bring down your 3. 11 goes into 33 3 times. So this part of the problem, 6,413 divided by 11, resulted in 583. And then I just bring down this. 583 equals 583. That was our last example. You can find more of my work like this on my website, supereasymath.com. Don't forget to like and subscribe. Did you find this video helpful? You can support this channel by donating to Super Easy Math through PayPal. There's a link to it in the description section below this video and on the Super Easy Math YouTube cover photo.